Hi everyone. So we're gonna start in a minute. So welcome everyone. My name is Flo. I'm Corporate Innovation Manager for the US branch of TrueSpares region. I'll be your host today for our tech meeting dedicated to hydrogen. Please note that this session will be recorded. So please let me know if anyone would be against it. And we're gonna start in a second. So first, we're going to start with the agenda for today. So after a short introduction of what we do, I'll provide some key figures about the hydrogen industry. And then we will move to the fireside chat with our experts today. Vincent Ruinet from ENGIE, Christophe Arnold from Airbus, and Severine Lalande from Total Energies to discuss the industry and tomorrow's big trends of innovation. And then we'll finish this session. We'll have a selection of innovative companies who will be presenting their solutions and products. So we will answer questions at the end of the fireside chat if you have any to our experts. And then you'll be able to react and ask some questions after the presentations of all the startups. So feel free to use the question feature of Livestorm to ask your question. All right, so let's jump into it with a short presentation of TrueSpares region and what we do. For some of you who don't know us, TrueSpares region is a catalyst for business and innovation. We partner with Fortune 500 corporations in order to support international companies willing to expand and set up business in the Paris region. So thanks to our presence and vibrant tech ecosystem located in San Francisco, New York, Beijing, as you can see here, Shanghai, and of course, Paris, we are in touch with over 4,000 international companies every year. So this unique relationship with large corporations on one hand, with innovative, fast-growing companies on the other hand, led us to create the Global Open Innovation Network about 5 years ago. Through this global program, we organize about 20 events a year to foster business and technology partnerships between large corporations and startups. Since the pandemic moved our events online, it allowed us to connect and get in touch with more people, more companies. So I would say it has been a pretty interesting experience. In terms of technologies and topics, we cover a narrow of technologies. As you can see, it goes from AI, IoT, and topics such as like factory mobility, and you name it. Today, we're going to talk about hydrogen. So first, I wanted to show you a brief overview of the hydrogen industry. Of course, it's composed of different actors from various industries. So you can see here on the slide, it's Linde, it's Air Liquide, Messer, Hydrogenics, Total Energies, ENGIE, etc., etc. And we can also find a lot of actors in sectors like transportation or construction, and we'll actually have some example during the startup presentations. So here are some key figures I wanted to share today. I wanted to stop on three main figures really quickly to set up the base of our discussion with the panel just after. We can see for the first one that today the global hydrogen generation market size is valued around like $121 billion based on a PwC report. So it's really big right now, but it's going to get bigger in the future, of course. Something important as well is that by 2050, hydrogen could be accounted for 20% of the world's final demand energy element. So it shows that H2 is the energy of the future, as we can say. And last, of course, in 2021, the market demand for hydrogen is around 99 million metric tons, and it's expected to reach 204 million metric tons in 2030. So you can see here the main prediction, and they will raise over and over in the coming years based on other industry transitioning their solution or product to hydrogen, for example. So those trends in industry where hydrogen is preeminent source of energy today, as we can see here on the slide, it's of course the manufacturing industry, the transport with planes and cars, for example. It's building construction and power generation. All right, so I'm not going to spend more time on this, and I'm going to move on to the market map. So to finish this overview of the hydrogen industry, I wanted to share this non-exhaustive market map with you. We designed it based on different players we have identified on the market. Of course, it's missing a few actors, but it gives us a good understanding on what is happening these days. I don't want to get into too much details, so if you're interested or have any questions, feel free to reach out to me. I'd be glad to share it with you or tell you how I've built it. Great, so without further ado, I'm going to invite our three experts today for the Fireside chat. So Severine, Vincenz, Christophe, you can join me on stage. Perfect, thank you. We're just going to wait a few seconds for Vincent. All right, so today we have Severine Lalande from Total Energies, we have Christophe Arnold from Airbus, and we have Vincent Ruinet from Engie. So thank you again for accepting my invitation and being with us today. I'm very excited to have you to discuss the different topics today. First of all, maybe, and to give some context to the audience, maybe you could all present yourself, tell us a little bit about you, the organization you're representing, and your current projects, maybe. Severine Lalande for Total Energies, do you want to start, maybe?
Sure. Glad to be here. Thanks for having me. So Total Energy is a new name of Total, reflecting the energy transition and the commitment to reach carbon neutrality of the company in the next year. So maybe a bit of color on me. I've done my entire career with Total, originally in exploration and production. I joined as a geophysicist, and more recently transferred to the gas, renewable, and power division. So my own career embodies the change and transition of Total. I'm currently with the venture team in San Francisco, looking to invest in startups in the different areas of the low carbon energy and transportation, but we'll come back to that.
Nice, very nice. Thank you very much, Severine. Christophe, you want to go next?
Yes. So hello everyone. My name is Christophe Arnold. I'm working at Airbus on the ZeroE project. I'm in charge especially on the activities related to hydrogen infrastructures and ecosystems. So first, many thanks for organizing this large cross-industry forum, giving traction and connecting the dots between hydrogen players. So the aviation industries, Airbus included, has committed to key industry-wide decarbonization targets, ambitious targets that cannot be achieved using existing aircraft technologies. And in that direction, we strongly believe in the potential of hydrogen, and we will develop further after. And a little bit about my background also. I started my career for Ariane in the ground segments, so really in the cryogenic management of fluids for our European launcher. That's it for the introduction.
Nice. Thank you. Thank you so much, Christophe. Vincent, yes. Do you want to present yourself maybe and present like some of your projects or like initiatives?
Yes, thanks. So thank you for having me to this event, and looking forward to exchanging on hydrogen. So yes, my name is Vincent. I'm an investment director in NG New Ventures. So NG New Ventures is the venture arm of NG. So we invest typically in startups, Series A, Series B, with the aim of also developing the business with NG. And a few words also about my background. I started in project finance and M&A with NG, and mostly on renewables. And since 2 years that I've been working in hydrogen. For NG, hydrogen is one of the key missing links to get to the transition, to the energy transition. So it's really one of the pillar of our strategy, and I'll be happy to dig more into that in the next few minutes, because that's a topic I'm very interested in.
Yeah, definitely. I'll make sure to ask you the question. Great. Well, thank you again for presenting yourself. Great. So maybe we can start our first subject. And of course, I wanted to start with general question, maybe one general question, because I'm pretty sure like not all the audience know exactly what hydrogen is for or how hydrogen is used for. So we can see that hydrogen right now is a very trendy topic, and everyone is pretty much talking about hydrogen because it seems to be like very important for the climate. So my first question would be like, why and how hydrogen is different from any other energy sources? Maybe Vincent, you had a comment on that?
Yes, of course. So yes, of course. Obviously, everybody talks about hydrogen. To get back to the basics from what I get is that today a lot of more organizations and states and countries are really taking the energy transition into action with objectives to get to net zero in the very near future in terms of CO2 emissions. And the solutions for that, especially for energy, is existing today, which are renewables. So think about wind, solar, etc. But as you know, these renewables, they're not, the electricity produced is not easy to store. And so the missing link for that is to find something that can store this energy in a cheaper way and in a clean way. And hydrogen for that appears very interesting because it's the most abundant element in the universe, right? It can be, so there's no risk of shortage. And if it's produced through renewables, then it's purely a clean source of storage of this fuel. Also, what is very interesting with hydrogen is that you can produce it mostly anywhere. So compared to like oil, where you need to dig at the right place, or other resources that are concentrated in some places, here you can in theory produce them anywhere. So that's also another very interesting thing about hydrogen. And lastly, what is very interesting also on the energy side is for some, you could say, and you could argue that batteries plus electricity could be the solution to store the energy. But we see that for some use cases where you need really a lot of energy, gas is probably the best way to store it and to get the energy. So industries like steel industry or mining industry, where you really need a lot of energy, then batteries are limited in that field.
Yeah, definitely.
Yeah.
You
can put aviation also, Vincent.
Yeah.
I would say it's maybe worth pointing at some of the debate around hydrogen. Let's not forget that today hydrogen is already used, but 95% comes from fossil fuel. So the real big topic around hydrogen is how to develop it as low carbon hydrogen, and there's many different ways to do it, and that's what's interesting from an energy provider. You can do. We will get probably into the different colors of hydrogen, but there's different ways that are more or less suited to each situation. So multiple ways to produce low carbon hydrogen is one interesting topic, and also multiple use. Some of the common use we know today are mainly done in situ. It's for refining, but mainly for ammonia fertilizer production. What we're aiming at today are all the future use of hydrogen in hard-to-abate domain. And I think the best way it reflects in Total's energy strategy is we realize we're today the number 2 in LNG, and we want to be in the top of the low carbon gases, which is an entirely different ambition, but is more point on the challenges of today.
Yeah, definitely, and actually, like with like the that's a good point, because like with the energy transition, right? People thought that like fossil fuel or oil companies were about to be excluded, if I may, from the energy transition, right? But we can see that with hydrogen, all companies can actually take part of it. So I would say, like, Severine, how are like companies like Total Energies transitioning and adapting into this low carbon hydrogen economy?
I think you're totally right. It's about transitioning in adapting and keep providing the relevant energy. So there's different way to produce low carbon hydrogen. One of it is to use existing production system, but capture the CO2 that is generated. So it's blue hydrogen. That's something that an energy company which has a lot of skills in gas management and subsurface storage management can obviously consider doing. And we are currently exploring some possible projects in this sense. The other one Vincent alluded to is about producing hydrogen from renewable energy. And as part of the transition, Total is moving more and more into renewable production. So hydrogen becomes the gas of choice to couple with high quantity renewable through electrolysis, and that's what we've actually doing with ENGIE on the largest green hydrogen project in France, which is a project near Marseille, where solar power helps produce hydrogen that is used in a biorefinery. So you can say this quickly, and it seems simple. It's actually a very high-tech project, because on the one side, you have intermittent renewable energy, and on the other side, you have a chemical process that requires, of course, continuous and stable influx of hydrogen. So it's a very interesting project that is already started and is likely to scale in the next year. Vincent, do you want to add on this one? Massilia?
Massilia project?
Yes, with great pleasure. So Massilia is an example of one brick of what we do at ENGIE in the hydrogen space. So for us, you need first to produce, then you need to transport, and then you use the hydrogen. So for the production, that's typically what we want to develop, is the kind of project of Massilia, where you've got big electrolyzers coupled with renewables to produce green hydrogen, and to really get to scale. Here the application is for a biorefinery, as Severine mentioned. And so once you produce them, and so what is also very interesting with this project, I think, is that I think we get something like 25 interested companies, LOIs of industries that are interested in getting the hydrogen or partnering with our project. So that really has a pooling effect on the hydrogen development in this region. So that's huge. After production, what you need to do also is transport the hydrogen. And on this, obviously, at NG, we have some pipelines of gas that you can also use and leverage to transport the hydrogen and also store. So we have a salt underground storage that you can also leverage on to store the hydrogen. And then the last one, and maybe it's also very interesting for Christophe and for Airbus, is the use of the hydrogen. And on this, we are developing several projects with the aircraft industry for airports, for example, or for ports. Also another hub is, of course, the cities for buses, etc.
Great. Yeah. And Christophe, actually, I had a question as well. Is it like with all those initiatives today that we can see, what's your opinion on that? Like, is it for you like the end of fossil fuel, or like what's your opinion on that?
Is it the end of fossil fuel? No, I don't think we can stop now the use of fossil fuel. What is important is to think about carbon capture. Our climate needs that we emit less carbon, and this has to be our goal, ultimate goal. Yes, to stop emit carbon. But fossil fuel, we may have to use it still. Yes.
Yeah, definitely. And so, can you tell us a little bit about the different like initiatives that you're doing at Airbus in terms of hydrogen?
Of course, yes. Coming back at the interest of hydrogen, hydrogen is light. Hydrogen has a high density of energy. So light, it's the first thing for an aircraft. It needs to be light to fly. Energy intensity is important, and after hydrogen is versatile. It can be used in several pathways. So first pathway, for instance, is it can be used as an ingredient for the production of the sustainable aviation fuel, like power to liquid e-fuel. And this is a very important one that could be blended up to 50% today, and in the next year up to 100% in our engines. And so we expect a tremendous scale up in the next years. Hydrogen can be used with a direct combustion. So in our engine, and it can be used also through fuel cell and electric motors. So back in September 2020, Airbus has revealed 3 concept aircraft, the Zero-E aircraft, where we have a turboprop with up to 100 passenger, 1,000 nautical miles. We have a turbofan concept up to 200 passenger, 2,000 nautical miles, and we have a concept also of a blending wing body, which is really interesting in terms of aerodynamic shape, capacity, volume capacity for the hydrogen. You know, one of the issues with hydrogen is the volume it takes, and with this kind of flying wing, we are able to store a lot of hydrogen. So you see a lot of concepts. We are developing the technological bricks up to 2025 after we launch a program, and our ambition is to put on the market a climate neutral aircraft before 2035.
Okay. Yeah.
And while Christophe is redesigning the aircraft, we try to make them fly with lower carbon fuel, I would say. And building on what you just mentioned, we have a project in Germany to produce synthetic methanol from hydrogen, which is done with one of the startup of our portfolio, Sunfire, at the Leuna refinery. It was actually announced, I think, 2 days ago. So it's the CO2 met 1 megawatt electrolyzer that is going to produce synthetic methanol using CO2 emissions from the refinery and renewable hydrogen. So it's one of the uses of hydrogen that is contributing to the transition.
Yeah, definitely. Yeah, thank you definitely for this input. It's really important indeed. And so Vincent, maybe I know you mentioned it like a minute ago, but I wanted to come back on the logistic chain. So we talked a little bit about the production, but can you tell us about the importance of the network to transport the energy carriers to support the development of hydrogen that you mentioned it like earlier? Can you touch a little word on that?
Yes, sure. When we talk about green hydrogen, we need to go to the places where the green hydrogen is the cheapest, right? So you can think about places like Sahara, the Gulf region, or South America, for example. Mm-hmm. And so there could be a business case to produce renewables there, and then send the energy back to the places where there's a lot of consumption, would it be North America or Europe. And in this particular type of setup, actually there was a nice report by the European Commission a few days ago that compared different ways to transport the hydrogen depending on the range, on the distance for high volume, and the results are quite easy to understand, right? So for let's say the shortest distances, probably pipelines that already exist that can be retrofitted at let's say low cost or limited cost are probably the cheapest solution. In the report, I think that the limit is around 3,000 kilometers. Beyond that, there are probably other ways that are more efficient, ways like ammonia, methanol, LOHC. So it's kind of carriers that are much more dense than hydrogen. As Christophe said, hydrogen is light, so it takes a lot of room. But the issue with them is that you need a lot of energy to transform hydrogen to those carriers and back to hydrogen. So if you only do a little distance, there's no use using them. Mm-hmm. So there may be a business case. For the moment, at least at NG, we don't see that commercial right now, but probably in the next few years or 10 years, it could be very interesting to use those carriers actually to do what I explained at the beginning, produce in countries where electricity is very cheap, because electricity is the biggest cost actually in electrolyzers. It's more than the majority, more than 50%.
Right. Yeah, definitely. And in terms of storing this energy, I know it's like well known that like renewable energy will be generated where it's needed in the future, so it will need to be stored and transported after, right? So hydrogen, is it the best way possible to store energy? I don't know, Christophe, maybe do you want to touch a word, or Severine?
Just a short word. It's maybe more the field of expertise from Severine or Vincent, but you know, in the aircraft, we intend to use the hydrogen in its liquid form, because liquid hydrogen takes much less room, still little bit, but much less room to be stored. And then it's also a good option to be transportation. We see projects with liquid hydrogen ships, for instance. well, just a comment on this, and I let other.
Great.
I think
Severine,
it's
yes?
hard today to qualify hydrogen as the best storage system. We are learning how to manage a grid where there's increasing part of renewable, and today there's different options. The cost of battery is dropping as well, but we know that they do not allow as long term storage, seasonal storage as we would like to. But what Vincent mentioned earlier points to the fact that today an entire infrastructure system needs to scale up to be able to integrate hydrogen. Dedicated hydrogen storage underground are still counted around just a few of them across the world. Pipeline accepting hydrogen are also limited. So it's a new infrastructure system to build, and that has to be done wisely, because as we say, it's a versatile molecule that can be combined, compressed, transformed into a liquid, and each use case has to be carefully modeled and assessed in order to be the most economic and sustainable.
Okay, yeah, definitely. And so, if we maybe like switching a little bit on price, for example. If we talk about like the cost of production, I know Severine, you mentioned the different colors, but when we talk about price, how do you consider like low carbon hydrogen compared to a gray hydrogen production, for example? Severine, sorry.
Yes, I think the price of low carbon hydrogen is not yet competitive with gray, but that's not the point. I mean, the point today is how do I get the low carbon hydrogen I need for my application with a lower cost. Carbon capture today is an interesting option that can be done at low cost, but there's still very few numbers of such large projects in the world. So where it's possible, and we are getting to the concept of hydrogen hubs, it's a very interesting option because you add it. In terms of green hydrogen, of course, we always think about electrolyzer working only with renewable electricity, but let's face it, today it's not the case around the world. So dedicated projects with 100% renewable electricity for hydrogen are just the first of them are emerging, and that's exciting. Today the cost is still higher, but again, I think we're already factoring in the fact that carbon emission have a price and need to be considered in all future projects. I think the concept of carbon tax is already in everybody's mind, thinking about such long-term projects, whether it happens or not in the different parts of the world. The commitment to net zero requires to factor this in. And on the electrolyzer side, I think we're seeing decrease of the cost and still monitoring the technology that can make things more efficient and cheaper.
Yeah, definitely. Yeah, it will definitely become like more competitive with other low carbon alternatives. Great. Well, thank you. Yeah. So you mentioned the hydrogen hubs, and that's one of the topics I wanted to touch upon today, because it's also a big trend. Like you said, to lower the production costs. Maybe Christophe, do you wanna explain maybe first what it is, like what are those like hydrogen hubs?
Yes, indeed. Hydrogen hubs, especially at airports, is a concept really important for us. This is an opportunity to bring the hydrogen at airports before the deployment of the aircraft. It enables to lower the costs, to develop the competencies, to have synergies between sectors, We can imagine the ground operation, the mobility sectors, a fleet of taxis, buses, the power, the backup power of or the heat of buildings, to be on the same infrastructure. So it's a way to share the capex, the investments, and it's really a virtuous circle, which de-risk at the end. It creates area where resilience to the fluctuation of the demand. So I think hubs is something that has to be worked across the sectors and can be beneficial for many stakeholders.
Yeah, definitely.
And after, I have a few very concrete examples, if you wish.
Yeah, sure. Yeah, sure. Please share. Yeah.
You may have heard, for instance, about the call of interest at Paris Airport, where we participated as in the jury panel. So the 11 companies in the final round has been awarded, and it was really interesting journey, you know, to meet all these companies from very different sectors addressing the whole value chain of the hydrogen, so, you know, from the production, the transport, generation, ground support equipment with the innovative process. So I think here we have a lot to learn in the creation of hydrogen hubs.
Yeah, definitely. Yeah, thank you actually for like sharing this initiative. It's actually a project with two Paris region, Airbus and Air France and ADP, which was like an open innovation project to transform, right, the Parisian airports into big hydrogen hubs to produce, of course, transport and distribute the hydrogen. So and actually we have winners today in the story presentation. So I will let them present their company later. Great, thank you. So
in front of you, at NG, I think we won two projects. So yes. We are in consortium for two projects. One for to develop a refueling station, hydrogen refueling station, and the other one is a bigger consortium to provide mobility for the airports. So necessarily for the planes, because it may be a bit too soon. As you said, I think you said 2035 in your objectives.
Yes, for the start, but we expect the hubs to be developed much earlier.
Of course, and so to prepare that, we are involved in a consortium to develop other type of mobility, the luggage carriers, for example, or the planes carriers or the buses, etc. on the airport, but also outside for the transfer of passengers, buses or other cars, etc. So it's a big hub.
Yeah, definitely.
Prepare for the hydrogen planes.
Yeah, planes and cars, like you said, and actually, you know, we can see that like transportation companies like Hyundai or Toyota, they're already manufacturing hydrogen cars, right? But I had a question actually about that. Like in terms of infrastructure, for now we don't really have the fuel stations, so we cannot refill the cars yet. So we can ask like on like investment standpoint. Do we need to drastically invest in those like distribution technologies to speed up the general use of hydrogen for cars? Maybe Vincent or Severine, yeah.
I think it's already happening in Northern Europe. There's 100 stations that are operating or in projects, and TotalEnergies through the H2 mobility network with 5 other industrial partners as 30 hydrogen refueling stations, which are all across Germany, Netherlands, Belgium, and France. I think we have to think carefully about the use of hydrogen for cars, because everybody knows that battery electric vehicles are getting more and more popular. One interesting example is the use for taxi, for example, and we recently joined Isetco, a taxi company in Paris, which has also other partners and wants to develop hydrogen for taxi, which is an important use because the speed of refueling is of great importance. Another rising use that is already growing is for buses, and Total has developed refueling station, private and public, in the Netherlands and in Belgium for buses. And this is an application that is actually growing both in Europe but also in the US. In California, there's already more than 50 hydrogen refueling stations.
Nice. Yeah, definitely. Yeah, Vincent, did you want to add something?
I guess, yeah, to solve this chicken and egg problem, as Severine said, you need probably to find captive fleets or use case where you're sure that the users will come back and have an interest to use your stations. And another example we can mention is also for the mining trucks. So with NG, we have a project with the Anglo-American to build a hydrogen-powered mining truck. So this year, it's the first truck in motion will be this year. So it's very short term also. And in this kind of use case, when you need to refuel quickly and get a lot of energy, it's probably very well suited.
Good.
Not to forget the long distance truck, of course. And that's another collaboration we announced recently with Eisen Motors, because long distance truck can benefit from the lightweight and long distance that hydrogen as a fuel can provide. And they can also operate on routes that make sense to create the hub of production at the refueling hydrogen station.
And the last point maybe also on this is the need to have public support, sponsorship, and subsidies to launch the projects. And in a lot of the projects that NG is doing in mobility, H2 mobility, there is either a public co-investor or grants from the Europe or France to support them and to start building the network of stations.
Yeah, definitely. Yeah, thank you definitely for that. Yeah, so maybe my last question, I would say that for some of you actually work for venture departments. So of course, my last question would be about like investment. What would you say be the main areas of investment when it comes to hydrogen today? Like, what is it for Henry? What is it for Total Energy? What is it for Airbus as well? For the Zero E department that you're working for, Christophe, maybe.
For Airbus, you know, Airbus invests a lot. Airbus invests hundreds of millions in research and development of new technologies to mature the aircraft platform to select the best technologies. And in the future, it will be more in the billion range when we launch the program. So yes, we need to invest, and Airbus, we need to convince also all the ecosystem to invest, because when it will come the day to deploy our aircraft, we need ready to operate infrastructures at airports with the involvement of the energy suppliers. So Total, NG, for instance, will be key players there. Airlines also, and airports, of course. So this energy transition needs big investments, and we need to make it together to give visibility on the demand, on the offer, and to be confident in this in the past to deploy all these streams.
Nice, yeah, very nice initiatives, yeah, indeed. Great. Maybe Severine, Vincent, do you wanna tell us like the areas of investment quickly? Yeah.
So I mentioned two investments we've already made: Sunfire in the solid oxide fuel cell, and Aizen Motors done on the trucks and heavy duty application. It gives you a sense that Total has interest all along the value chain. The production of low carbon hydrogen, so both green and blue is of interest, as well as providing the fuel to the diversity of clients today that we are working with on their decarbonization targets. So whereas it is for synthetic fuels, where the liquid fuel will not be substituted or shipping to hydrogen stations, all of those areas are of interest for us.
Okay. Very nice. And Vincent, maybe?
Yes, for us, yeah, at NG New Ventures. So in addition to the R&D activities of NG, what we're really looking for is startups that will bring something in terms of business development for NG across the value chain, from production to up to the refueling station, basically. And to give one concrete example, last year we invested in a company called H2Site in Spain that is producing hydrogen from different gases, would it be methane, methanol, ammonia, etc. And so this is really a breakthrough technology for decentralized uses. And so the interest for NG is to then partner with this technology and sell hydrogen to clients using this very specific technology. And today we are in this discussion to deploy them for industry, for mobility also. So that's typically the kind of techno investment in hydrogen that we want to do, where there is a really something for us in terms of business development. And what we would bring, of course, is the access to the clients that we already know, and that to whom we already sell different services and assets.
Okay, yeah, definitely. Great, very interesting. Thank you very much. So maybe before we end this panel session, I just wanted to come back on the questions from the audience. So we have 3 questions. I'm just gonna take one just because we need to stay on time for the startup presentation. So maybe I'm gonna take the first one by John Soring. So he says, please share your company's opinions regarding the production, storage, transportation of green ammonia as a chemical to better store and transport green hydrogen. Who wants to answer that like quickly? If anybody has an answer, of course.
I think I gave some ideas previously, but I will develop it. So what we see is ammonia is a great way a potential great way to store hydrogen because it's much more dense. So it could be an interesting for long-term transport, and so also to fuel heavy mobility, ships, etc. So I would say that it's an option like others, like LOHCs or other carriers.
Okay, makes sense.
Yeah, I agree that today we have to weigh many different options. Each have their cost and their CO2 footprint and their level of maturity, but definitely ammonia is one of the interesting options.
Great. Thank you so much, Vincent, Christophe, Severine, for your insight Thank you again for accepting my invitation today, and please stay in with us for the second part of our presentation today. Thank you. Bye-bye.
Bye.
Bye-bye. Thanks.
Great. So today we're going to have so 5 presentation. We're going to have first Jean-Louis Kindler for Waste to H. So I'm going to share your presentation, and you can join me on stage, Jean-Louis, if you can.
I'm not sure whether I can. Well, apparently I could. Hello.
Perfect. Thank you. Thank you so much, Jean-Louis. And the floor is yours to present Waste to H. And go ahead.
Thank you. I understand I have 5 minutes, so I will try to be super quick. What you see here actually is perfectly in line with one of the keywords we heard earlier during this panel discussion, talking about hubs. And really the concept we are advocating for here with our waste to hydrogen solution is a system that can be deployed locally, close to where the waste is being processed, close to where the waste is being produced, and use this decentralized solution to produce hydrogen, which of course will be renewable, produce hydrogen that can be used directly either on site or near the site where it is produced. And we'll go to next slide, or maybe I can move my slides. Yes, I can move my slides myself. Perfect. And so there's another very present keyword in the hydrogen industry today, which is so-called green hydrogen, or that I prefer calling electrolytic hydrogen, being produced out of electrolysis powered by renewable electricity. I'm a big fan of that, don't misunderstand me, but I think we also are facing another issue that needs to be addressed today, which is the problem with waste. And today we have approximately 2 billion tons of mixed waste that is sent to landfills every year. And very conveniently, I think it's very important to realize that those 2 billion tons, it's roughly about 100 million tons hydrogen potentially. So in the first figures you mentioned, 200, I think it was 200 million tons demand in 2030. I'm not saying that we will literally take those 2 billion tons and turn them all into hydrogen, but it definitely, the message here is that definitely waste is a very, very significant potential source of hydrogen if we handle it well. And it is also something that is even probably more important. This waste, it does contain carbon, and typically in the systems that we are engineering and commercializing, we use the carbon contained in the feedstock as the energy source to extract and produce the hydrogen that is also contained in the feedstock. So it is a fully self-sustainable process, and it is a process that, again, unlike electrolytic hydrogen, it is a process that opens the door to full carbon negativity, because typically municipal solid waste is, in average, once the inerts have been taken out, inerts being metal or glass. Once the inerts have been taken out, municipal solid waste is approximately 80 to 80% renewable, which means that connecting our systems with carbon capture and sequestration solutions effectively leads to a solution, to a pathway where those systems, which will be deployed as a network, will be carbon negative and will be a gigantic carbon sink, which is, being carbon neutral is great. Being carbon negative is obviously much, much better. This solution that we are commercializing is about 20 years old. I actually was responsible in Japan in 2002 for the engineering and construction of the first system. You can see the photo, the small thumbnail on the left. Our partner, Japan Blue Energy, has developed actually 3 generations from this first pilot. And today we have a system in operation in Joso, which is near Tokyo. That's the system, the small thumbnail on the right. We have recently deployed another system in Tokyo on a wastewater treatment plant to process sewage sludge. And we are currently building another demonstrator that will be deployed here in California in September, October this year. Typically, our standard solution will process approximately 24 tons per day of waste, which means extracting 1.5 ton hydrogen. That in turn means about 300 vehicles, 300 passenger vehicles, full tanks per day. It's interesting to note that it is roughly the equivalent of what a gasoline stand is doing today in terms of vehicles now being served. So of course, well, it's probably not really needed to talk about applications. One thing though that I think is important to note, 2 things. First, again, it opens the door to a carbon negative production of hydrogen, which will not use or would not use renewable electricity, leaving the renewable electricity for other users of the grid. We mentioned earlier the emergence and the rapid emergence of battery electric vehicles. This is where we will be needing renewable electricity. So let's use waste and produce hydrogen out of that waste. Another aspect of this is that it's a fact that hydrogen as a fuel is not needed everywhere today, but power is needed everywhere. And this solution, again, being local, being decentralized, can be deployed for power generation. And for example, even in Western Europe or in the United States, North America, for example, to power data centers or other energy hungry solutions. Typically, so we are today reaching commercialization phase. We have, as of today, we have about $500 million worth of projects pipeline, both in North America, Western Europe, and some other exotic places. I'm happy to discuss further. My contact information is here. And I would also like to note that this illustration you can see here with a small 1 ton per day transportable system right next to a hospital. It is a concept that we are also advocating for, the local on-site processing of medical waste. We don't want to spill or we don't want to distribute contaminated waste all over the place. So treat this waste on-site and produce renewable electricity, renewable power for the hospital on-site. Thank you very much.
Thank you, Jean-Louis. Amazing solution. Thank you for your presentation. Great. So next, I'm gonna call on stage James Grieve for Micro Era Power. Hello, James. How you doing?
Just great.
Great. Yeah, the floor is yours, and yeah, you can present your company, Micro Era Power.
Yes, hello. I'm James Grieve, CTO and co-founder of Micro Era Power. We're a Rochester, New York-based company. We also have a small office in Newcastle, UK. We're developing Thermo Plus, a smart thermal energy storage for heating and cooling of commercial buildings. How do I change slides? Do I go down? Can you? Oh, there we go. The issue that we're focused on is peak electricity. With the increase in use of renewables, when renewables are abundant, electricity will be cheap. And when demand is high or renewable production is low, energy will become more expensive and is already carbon intensive. Today, the peak is often related to summer air conditioning. In the near future, it will be electric vehicle fast charging as well. And when we switch to heat pumps and decarbonizing heat, there will be a severe winter peak. So for all of this, energy storage is essential, and the opportunity is growing. So Thermoplus is a hardware and software solution. Our mission is to store low-cost, renewable intensive energy off-peak and then deploy it on-peak. On the left, you see a picture of one of our tank designs. It's a plastic tank that's buried, and the two tanks there that you see store about 1 megawatt hour of thermal storage. And the graph on the right is a electric load profile for a hotel over a 7-day period. And the concept is to, for example, store air conditioning at night and then use it the next day. So you're filling in the off-peak and you're reducing the valley. You're reducing the mountain of on-peak. One thing that you can see here is the electric demand is more severe towards the end of the week. I think that's typical for a hotel that's maybe busier on Thursday and Friday and Saturday night. So what's different about Thermoplus? As I said, it's a hardware and software solution. We have a unique phase change material that stores both cooling and heat. So the same tank can provide value in both the summer and the winter seasons. In terms of software, we use smart controls via the cloud to optimize the system for cost saving behind the meter and also for grid interaction for renewable energy storage and peak load management. And in terms of ongoing value, we will do remote monitoring and field service, providing recurring revenue to Micro Power and our partners. We've been talking about hydrogen today, and of course this is a different technology, but in our minds there are three main energy storage technologies for the future. One is lithium batteries, of course. The other is electrolyzers and hydrogen fuel cells, and in a way Thermoplus is in the middle. Lithium stores electricity, fuel cells store perhaps hydrogen or ammonia. We store cooling and heat. With the same active material at temperatures that are useful for air conditioning and heating and hot water for buildings. Lithium batteries likely are only viable for a few hours of storage and are quite expensive and actually are not very efficient. So we have some advantages in terms of it's cost effective to do 1 or 2 days of storage with Thermoplus. And when you pair our system with geothermal ground loops, perhaps you could do 7 or 10 days of storage economically. The big advantage, of course, is the price level. Our active material is just $1 or $2 per kilowatt hour, so much cheaper than lithium, and fuel cells are clearly the most expensive and the least efficient. Again, all of these technologies have a place in the market, but the point is that we see Thermoplus as a scalable solution that can be pretty universal. The other thing to mention related to the discussion today is Thermoplus pairs very well with fuel cells. For example, if you have a 1 megawatt hour thermal battery and a 100 kilowatt fuel cell, you can produce more than 3 megawatt hours of heating over a 24-hour period. So putting the two together could make some sense. In terms of unit cost, a 1.2 megawatt hour study that we did showed 143,000 installed cost, 2.6 years payback for the customer, and significant recurring revenue for Micro Power and partners. In terms of market, we see a $34 billion global market paired with renewables, and we're planning to launch in the U.S. market where there's very expensive peak electricity. Here's our management team. I have a background with Delphi Automotive, which of course was a substantial company in France. Now that operation is part of BorgWarner. And we're currently completing a seed round. We have 500,000 committed from a current investor to invest in the business and tech teams. We're also negotiating a large grant from the state of New York, so we need some cost share to support that. So this is micro power with Thermoplus, smart thermal energy storage for commercial buildings. Thanks.
Thank you very much, James. Our experts today actually mentioned that like the importance of storing energy. Indeed, thank you very much. And we're gonna continue with the presentations with Paul Madden for Eco Energy International. So Paul Madden, if you can join me on stage.
I'm
Great.
there.
Hey, how you doing?
You got me
Great. Here is the presentation, and the floor is yours.
Okay. So how do we advance it? We'll click on the side here. All right. Thanks to the previous speakers, I don't need to spend a lot of time on this, other than to emphasize the fact that the world today produces 2 billion tons, which was spoken of earlier. And even with all of the recycling that we do today, half of that goes into the landfills, and almost 95% of that in the landfills is organic waste, which produce methane and carbon dioxide. And we all know that methane is 20 to plus times worse than CO2 for climate change applications. So here we're saying that organic waste produces 800 million tons of CO2 equivalent. So that is a problem. The demand for hydrogen we've talked about briefly. A report by Strategy says that by 2050 it'll be 530 million tons requirement. People can argue the numbers. So we have a solution that handles both problems, similar to the previous discussion on waste energy. Our technology is totally different than any other technology. Ours, it does not rely on any heating process. We're actually an exothermic process, catalytic reaction, and convert the materials directly. And in doing so, we sequester the carbon in the effluent. Real quickly, this is the process. I'm not going to go into details for time, but we put the materials, the carbon-based materials into the solution, run it through the reactor. The gas, hydrogen, 98 to 99% pure, evolves off. We condense it to take out the moisture, compress it. And if you need it at 5 or 6 nines, then we run it through a PSA process to get that last little bit out. And, I won't go through all the details on this, but these are some of we can take many types of fuels, and they've all been proven. Lower temperatures, lower pressures, lower cost for capital equipment. So applications, this is just a short list of some of the applications. Municipal solid waste recovery facilities are a #1 target. Where you have existing facilities in place, you can set this plant right next to it and run the material through it, which eliminates probably 90+% of the material that would otherwise go to a landfill. We discussed airports for the sake of the discussion of the Paris application. Distribution centers, we're in discussions with Amazon to take their waste and make hydrogen for their fuel cell operated tow motors, forklifts, farms and ranches. Biodiesel is an excellent application. Glycerol is a beautiful feedstock, and lignins as well. Breweries and so forth. Coal is actually kind of an exciting one we're working on. I'll touch on that. I'm not going to go into details on the competition since we talked a little bit about that as well. But steam reformation is the way it's made today, and hopefully most of you know about that as well. And of course, electrolysis is a competitor, but there's much more energy intensive, and it relies on renewable energy. And technically, today, that renewable energy could be used to offset fossil fuel energy instead of being there. So you can argue that one. And these are all the participants that have been involved in developing the technology. We have 25 patents, US and international, on this. We've been granted the Solar Impulse Foundation Efficient Solution Award, and we were recently recognized by Tech Briefs magazine, which is a NASA publication, for our reducing climate change with waste to energy. How we're going to do it? We plan. TechNip is a company that just recently changed the name from TechNip FMC to TechNip Energies, based in Paris and Houston, and we are in collaboration with them. They will do the actual construction of the facilities worldwide, and we're talking about a facility right now in Tasmania that they will be working on. Real quickly, the team, we don't need to go into that. Traction. Last week we signed an MOU with a coal company in Australia that will start in the next 60 days. That will install modules that will convert 10 tons of coal to 2 tons. This is being conservative of hydrogen. And we've got another MOU with a Vietnamese company, and these are others that SoCal Gas wants us to put these plants so that they can inject the hydrogen into the gas pipeline. Currently seeking 10 mil that for a production unit that will then take 25 tons of municipal waste, produce 2 tons of hydrogen, and pays for itself in 24 to 30 months. And if multiple units are funded at the same time, they will have a faster payback, obviously, because the cost will be less. Summary, we talked about the hydrogen. We are sequestering the carbon. This is definitely a green hydrogen application. And the discussion on electrolysis, again, the only green one is untrue. If we were only in the United States, if we only did 3%, it generates 5.4 billion in revenue. And this is a bridge between for the hydrogen economy, because you can put this on farms, and you can put it at waste treatment facilities and the like. That's the last slide.
Great. Thank you. Thank you very much. Very, very interesting again. And thank you. Thank you again. Great. So we're gonna continue with John from Universal Hydrogen. So John, yes. Perfect. Great. Hey, how you doing, John?
Great. How's that? Can everyone hear me okay?
Yes, I can hear you perfectly. The floor is yours for Universal Hydrogen.
Okay, thank you. And thank you for the invitation. Hi, everyone. My name is John Gordon. I'm one of the co-founders of Universal Hydrogen. I lead all of our legal, regulatory, and partnership efforts. I'm going to try to switch to the next slide. Perfect. Our senior leadership team and advisory board are shown on this slide. As you can see, we have an incredible breadth and depth of experience on the team. Paul Aramenko, former CTO of Airbus, John Paul Clark, one of the top aviation engineers in the country, if not the world, and our advisory board as hopefully some familiar faces. So what brought us all together was a shared frustration with the fact that aviation really has no credible plan to meet the Paris Agreement emissions targets. And why that is especially frustrating is that there's a clear solution, which, as we've discussed, is hydrogen. Hydrogen is, hold on a second, guys, could you keep it down a little bit? Sorry, I'm in the engineering room. So hydrogen is in many ways the ideal aviation fuel. It's lightweight, it's safe, and green hydrogen is increasingly cost competitive with jet fuel. What it lacks, as we've discussed today, is a distribution infrastructure. And so that's the problem we set out to solve, not on a 10-year, 15-year, or 20-year time frame, but by 2025. We want to be in revenue. Is everything okay? We want to be in revenue service for regional aviation by 2025. So how are we going to do this? Much like Tesla, we believe you need to tackle the entire problem. So we set out to create an end-to-end solution to enable the connection of production with consumption. How do we do that? So what we've developed, our solution, is a modular capsule storage system that allows us to safely transport hydrogen as you would normal freight in a common shipping container by truck, rail, or ship. There are many advantages to this approach. First, it allows us to connect hydrogen production and consumption in a flexible way. We're able to source hydrogen efficiently where there is affordable renewable energy. And second, it's cost effective. Our capsules can be stored on the airport in a normal hangar without special equipment or infrastructure, and they can be loaded on and off the airplane with existing cargo handling equipment. Finally, last but not least, it's safe. Our capsules employ advanced monitoring, venting, and safety measures that monitor the hydrogen at all aspects of transportation and consumption. We maintain hydrogen at all times in a safe and highly monitored environment. This is an argument not just for regulators, but also for passengers who need to be comfortable flying on a plane powered by a new type of fuel. Of course, delivering hydrogen is only one part of the solution. Our goal is to address the entire hydrogen value chain, including its initial use cases. That's why we are also developing a retrofit kit for the ATR 72 and Dash 8 regional turboprop aircrafts. See the engineering rendering in front of you. As shown on the slide, it involves minimal changes to the aircraft and can therefore be certified on an expedited timeframe. We believe we are on track, as I said, for this fully retrofitted aircraft to enter into commercial service by 2025. And behind me, you can see the subscale powertrain that we've already developed. And in the next 12 months, we will be building in this space the full-scale megawatt class hydrogen powertrain, which will be the world's first at that power. Finally, a plane flying by, I'm at the airport. Finally, our solution is not just for aircraft. We envision creating multiple sizes and types of capsules for a variety of applications, including heavy trucking, rail, eVTOL, and even ground support vehicles. So that's my presentation. Thank you again. And I will now turn the floor back to you.
Thank you, John. Amazing solution. Great. Thank you again. Our last presentation for today will be Bertrand Gauthier for H3 Dynamics. Bertrand, if you can join me on stage.
Hello, everyone.
Hey, Bertrand, how you doing?
Good. I'm the last one.
Perfect.
I hope I won't be too long.
Yes.
So thank you, Choose Paris region, for inviting me to present H3 Dynamics. So I'm actually based in France, but we're a global company, and we're building technologies to decarbonize air mobility and also to leverage air mobility in order to decarbonize some services in the field of industrial inspection or in air transportation. So how do I, here. Okay. So as I mentioned, we're a global company. We started in Singapore, but we decided to go global very quickly. We've set up a team in 3 continents, covering each topic, as we're covering a number of industries: robotics in Singapore, hydrogen electric propulsion for unmanned aerial vehicle in the US, and hydrogen electric aircraft in France. We're basically stacking technologies to create fully integrated solution that would allow the development of a true hydrogen electric aviation in the next few years. You know all the benefits of hydrogen, as the other people talked about it previously. So I will not spend some time on that. Quickly on our history, we're from the hydrogen world, and we're entering into aviation, and I think that's our strength. Our story started in 2003. We have common roots with Horizon Fuel Cell Technology, and Horizon gave birth to independent companies on different markets. Horizon Education in the EdTech, Hyzon Motor that was mentioned earlier by Severine, Lalande, and H3 Dynamics, which is focusing on air mobility. So this is about Hyzon. So Hyzon basically focuses on heavy vehicle mobility, and H3 Dynamics is doing the same on the electric flight. Our story has always been to start small and think big, and have a big ambition. So that's the story of Horizon, starting with a very small fuel cell and now into the truck industry. And what we're doing now with the fuel cell, with the air mobility sector is the same. We start small with drones, and we go bigger in the next few years with hydrogen aviation. So we've been flying drones on hydrogen since 2006. So this was actually in the US, in California. And we did a number of projects that are now well known. And I think we're the company that powered the most, the higher number of hydrogen electric drones to date. Again, what I want to say is that we're flying now. So these are real products we're selling. Ultralight fuel cell technology that converts hydrogen into electricity. And we're flying drones with them already today. We actually have our own hydrogen electric drone design. We've decided to go into that direction to learn how to really make an hydrogen electric platform and how to integrate completely a hydrogen electric technology into an aerial vehicle. There are lots of challenges ahead, so we think learning on small systems, going to market quickly will help us learn and grow into bigger platform, being for larger cargo drones and soon into hydrogen aircraft to transport passengers. So I'm going to go fast on these ones. Some references, again, Aerodeft is one of our clients. We have quite a big project in France right now with ISA Super-Aero, with the goal of building the liquid hydrogen electric fixed-wing drone capable of crossing the Atlantic. And here we are really pushing the limit of the technology. And based on that learnings, we'll be able to apply liquid hydrogen to other aerial platforms. As this is an event from Choose Paris region, I wanted to mention that initiative from them and Group ADP, RATP, aerial mobility, around aerial mobility, urban aerial mobility, where we've been selected to show some of our technologies, and we're the only one to really represent the hydrogen community. So we hope to show different types of vehicles and propulsion systems. I will end on this technology. We want to standardize as much as possible the propulsion to make it easy to integrate hydrogen into aircraft in the future. And this is something we announced in 2018. And the idea of distributing not only the electric propulsion, but also distributing the storage of hydrogen into pods. So this is a concept that has been reused by other companies, and we think this is the way forward for a number of aerial vehicles, being drones or aircraft. So we're building now several of these propulsion pods, and you will see some news in the next few months about that. This is, of course, connected to the infrastructure, and we want to make sure that the hydrogen we use is as green as possible. This is about the announcement we made in 2018 with our Element 1 aircraft concept. There will be more news in the next few months, so feel free to get in touch. Here is my email. Thank you very much.
Very impressive technology. Thank you, Bertrand, for your presentation. Thank you for the shout out for Truth Paris region, of course. We were really happy to have you in there. Great. Bye-bye. Thank you to all the presenters. I hope to see you soon. To end this presentation, I just wanted to show you the schedule for the next tech meetings. And for the next one, it's going to be on July 7th for San Francisco, and it's around artificial intelligence. So I hope to see you there. If you have any questions, you can reach out to me either on LinkedIn or email, and yeah, I'll be happy to connect. Thank you again, everyone, for coming by, and have a great rest of your day. Until next time, bye bye.